Well, hello, welcome to this tutorial in which we will see a demo of the Red Wells tool developed in order to simplify tasks of welding numerical simulations. Uh, it is an ACT extension for ANSYS, and the meaning is rapid evaluation of distortion in welding structures. And as we will see, the tool has two main capabilities or two main functionalities. The first one is to simulate or to calculate welds in which we already know the welding sequence. We know what do we have to calculate. And the second one is to ask the system help to look for or to search the optimal welding sequence and also get the results of this optimal welding sequence in case we don't know it, that it is most of the cases. This first part will focus on the simulate or the calculation of these welds when we already know the welding sequence. It will be enough, trust me. So to do so, I have opened ANSYS and I have loaded a project that it is already prepared to this little demo. If we go to ANSYS Mechanical, we can see the loaded project. If we take a brief look of the project, we can see it is a structure formed by 5 main bodies, 5 solid bodies, and between all of these bodies there are some welds that we want to calculate. So in this case we have 4 vertical welds. I hope you see them here, over here. Two horizontal welds in the outside, and trust me, 2 horizontal welds, one in this side and other in the other side, in the inside, 2 horizontal inside welds. So we have 2 and 2 for horizontal and 4 verticals. We have 8 welds to join these structures. If we take a detailed look, we will see that these welds are formed by 3, or are going to be made by 3 passes. The first pass is represented by this first bead. This is the second one, and this is the third one. This is just using the logical order. You will have to put this one first, this one second, and this one third. So if you agree with me, we will need 24 beads in the welding sequence to complete all the welds of this structure, because we have 8 welds formed by 3 passes or 3 beads each. So once we know a little bit about the project, we can see, or we can focus in the extension. When you load the extension, it will appear a new tab on the main menu of the ANSYS workbench, because this mechanical is opening in workbench, and this tab contains the 4 principal or main options. This is adding a weld. It also includes the possibility to add a simple support, to add a sequence optimizer, and finally the help that just will show some documentation of the help of the application. So in the other ones, I will explain. The first one is adding a weld that will add or will create a weld object in our analysis. The weld object will be empty, so we will have to configure to adapt it to our project. Then adding a simple support will help us just to replicate that the structure is on the floor or is having any support. And finally, the adding sequence optimization, that it is out of the scope of this tutorial, will add an algorithm also unconfigured to look for this optimized sequence that we already talked about. So once we know all the options we have, let's see, we will have to configure a little bit our analysis first to adapt to the problem. So I have already added the gravity, some displacement are fixed, and and I established that the structure is on the ground, on the floor, so we can focus on the weld. So by clicking on the Add a Weld option, we can see that the system created this weld object, but as I said before, is unconfigured. These are the default options, so we will have to modify them or to configure them before we can trigger the calculations or to start analyzing. Let's see these configurations. Let me first start with the last one. This is not modifiable because this is inherited from this temperature. So if we want to modify, we will have to modify in the analysis. Then the rest of the configurations are first the displacement, the results type, in which we can pick the type of analysis we want to, or the calculations we want to do to this weld. In this case, it is only allowed to be displacement by the moment, but we are planning to add stresses or other calculations. Then we have the filler material that could be set to stainless steel or carbon steel. It is representing the material that will be in use in the welds, and it stores all the material properties and loads them when needed on the calculations. Then this, let me open it a little bit more for you. Okay, so now you will see the next one is in which we can decide to use or not an interpass temperature, and if we set to yes, for sure we will have to also configure the value of this temperature, but by the moment we will let it to know. Finally, the last but not the least, in fact the most important and maybe also the most complex configuration we will have to add to our system is the bid order. The bid order is a table that if we will take a deep look into it, it will ask for bids. Any row that we add, it will be a new bid. So in this case, in our analysis, we will have to configure 24 bids, in which it first asks for the order of this bid. The scooping method will help us to set the body of the bid by picking one, by selecting one of the list of name selections, or whatever. Then indicate if it is the last bid or not. And finally, the tag welds to consider in this bid. So I will start. I will do the first with you, and then I will do the rest behind the cameras. I will set one because it will be the first bid, but it could be in any order. I can establish here 24, and this will be the order that it will follow. It doesn't matter the number of the row, it matters the bid order we establish. So in the first one, if we set geometry selection as a scooping method, we will have to go to geometry then, and look for a body and apply to this geometry. So this bead, the first bead will be this body. The last bit is set to no and should be set to no always, because in this case last bit only had to be set to yes when we are configuring the last bit of the welding sequence, and we have set yes to the interpass temperature, because if you see it's interpass temperature for all but last bit. If we set the temperature to no, then it doesn't matter, the last bit we always consider it as no. So finally the tag welds, it displays all the name selections I have created on my system here, name selections, and I pick the one that is including the tags of all my structures. If you have seen it, you maybe have seen it on the tag welds, I have already configured all the name selections for all the welds. It is going from 1 to 8, the 8 welds we have, and inside them I have it divided on weld 1, bit 1, weld 1, bit or pass 2, weld 1, bit 3, so on. So it will be easier for me to do it in this way. So I will keep configuring all the bit order, and I will be back when I'm done. So see you. Okay, so here we are back on the configuration of our system. As I have promised, I have done some work out of the cameras. I have configured or finished the configuration of each bit. If you see, they are going from 1 to 24, and they have different name selections representing a different bed for each. Then they have all of them set the last bed to no, as I already explained, and the tags, because this name selection have all the tag welds of the structure, so it will be okay to apply all the changes now, and it will set the object to ready. So now we can start our analysis, but first let's see the configuration we still have. There is another parameter called optimize yes or no. In this case, this parameter, as you will guess, is not affecting us, because it is only to say it if it will be considered or not by the optimizer algorithm. So in this case, we don't mind, and yeah, now we are ready to start our analysis. Before we can set the results we will want, we want the total deformation, and we can set it to the last step of time. We can add some more deformation in other steps, but I think the most interesting in this case will be just the last step of time. So now we are ready to start calculation. So if you see here, it starts calculating. Okay, so here we are back after some performance time. I let the system working. As you can see, it has already finished its calculations, so no more calculations here. I'm not really sure if I already told you, but we added a total deformation in our results, and the system loads the information of the last step of time. This could be changed to any step. Each step represents the welding of a bit, so a welding pass, and the node with the maximum displacement, that it is 10.77, and is this node, and the node with the minimum one, that it is in the bottom, in the blue part. And this will be considered the result of the simulation, 10.77, and we also could see an historical of these steps I mentioned, in which the first step will be the first pass, creating a distortion of 1.99. The next steps are worst because you are welding more points, and finally sometimes some weldings will reduce the amount of displacement, and we finally all in all have this 10.77 that is the final result. And well, that's pretty much for this tutorial. I hope you have enjoyed, and if you enjoyed, just please, I encourage you to look for the second part of this video, in which we will see if we can get a better result with the sequence optimization. Thanks.